Hello everyone, my name is MD Al-Samil Amin Rishat, the University of North Texas, and today I'm presenting our work, Responsible AI Assistant in High School Cyber Education, Strategic and Root Cause Analysis. This study looks at an important question. As generative AI tools become more common in education, how can they be used safely and responsibly in high school cybersecurity learning? In general subject, AI assistants may help with the explanation and tutoring, but cybersecurity, it's different. It is a dual-use domain, so even a small mistake or overly detailed answer can create real safety concern. Because of that, we wanted to examine both of the benefit and the risk of using AI assistant in this setting. In this presentation, I'll briefly cover the motivation, our research question and methodology, the SWOT and Fishbone analysis, key implication, and the practical recommendation for educational use. Let me begin with the broader context and why the problem matters. This slide gives you a high-level overview of the paper. Generative AI assistants are increasingly being used in classroom to create explanation, example quiz, and short learning materials very quickly. That creates clear education value, especially for teachers and students who need fast instructional support. However, in cybersecurity education, the same tool can also generate factual errors, misleading advice, or technical details that are too concrete and potentially inappropriate for younger learner. So the issue is not only usefulness, but also safety boundaries and governance. To study this, we used a qualitative and evidence-driven approach based on two frameworks, SWOT analysis, and the second one is Fishbone root cause analysis. The SWOT analysis helps us understand the strategy landscape by identifying strength, weakness, opportunity, and threats. The Fishbone analysis helps us move deeper and identify why unsafe or problematic outputs happen in the first place. Our main findings are the AI assistants offer fast and scalable support, but they also show inconsistent safety behavior. At the same time, there are real opportunities for structured cyber awareness education, while major threats include dual-use threat and misuse acceleration. Now I will explain the context that motivate this study. The motivation for this work came from the very rapid adoption of large language model in education. In a short period of time, systems such as ChatGPT, Gemini, Claude, Grok move from being research tool to becoming widely accessible educational assistant. Teachers and students can now use them almost instantly for explanation, drafting, summarization, and question answering. But security is a high-risk educational domain. A wrong answer about phishing, password authentication, or device protection is not just an academic mistake. It can influence how students behave in real-world digital environment. There is also an important research gap here. Existing study on AI in education often focus on general learning support, productivity, or maybe user satisfaction. But cybersecurity introduce added constraint. Explanations must remain educational while avoiding operational details that would facilitate misuse. Another important concern is learner overtrust. This model often sounds fluent and confident, but when they are uncertain, in a classroom, especially in cybersecurity, that can be dangerous because students may accept inaccurate or unsafe information too easily. So our study is motivated by this intersection of these issues, these three issues actually. So rapid AI adoption, the high-risk nature of cybersecurity, and the need for safer classroom deployment. Based on that motivation, we defined three main research questions and selected a methodology that could address them clearly. This study is guided by three research questions. First, what are the benefits of AI assistant in cybersecurity classroom? Second, what obstacles and threats need to be addressed before safe deployment? Third, what cause unsafe or incorrect output in the first place? To answer this question, we designed a methodology with two major goals. The first was to collect evidence on how responsible AI assistant respond to cybersecurity related classroom prompt. The second was to analyze both the strategic implications and the root cause of failure. For data collection, we constructed a reproducible prompt set that reflect common cybersecurity course needed. This included an educational question, ambiguous request, and gray zone prompt, where the user intent may be unclear. We also conduct a literature review covering AI in education, cybersecurity education, AI safety risk, and classroom constraint. This helped us grounded our analysis in prior research rather than treating the problem only as a technical issue. Finally, we applied to analytical framework. The SWOT analysis was used to organize the strategic adoption landscape, and the Fishbone analysis was used to map root cause behind problematic output. I'll now move to the first analytical framework, which is SWOT analysis. These slides present the overall strategic landscape throughout the SWOT framework. The value of the SWOT here is that it allows us to separate internal and external factors strength and weakness reflect what is inherent to the use of AI assistant in this context. Opportunities and threats reflect broader institutional and environmental conditions around adoption. On the strength side, AI assistant provide rapid content generation and adoption instructional support. They can explain topic, they can summarize concept, or help produce answer awareness-oriented classroom materials quickly. On the weakness side, we found variables output safety across model. The same kind of prompt may lead to different level of reuse, refusal quotient, or detail depending on the system. We also observed limited verifiable when outputs are not grounded in reliable source. The opportunity include standardizing prompt templates, integrating teachers more directly into the workflow, and using monitoring process to improve quality over time. The threats are especially important in cybersecurity. This include dual use concern, escalation through repeated prompting, and the risk of trust or reputational damage in harmful outputs are shared in classroom. The next slide explains this SWOT dimension in more details. Here we break down each SWOT dimension more specifically. Under strength, one important benefit is rapid content generation. AI assistant can produce awareness content, short example, and explanation based on material efficiently, which can reduce preparation time for educators. Another strength is constant awareness support for topic like phishing, two-factor authentication, malware awareness, and safe practice. The system can often provide clear and accessible explanation. We also saw a safe redirection pattern in some responses where the model avoid harmful details and shift to word prevention or reporting. Under weakness, the most significant issue is variable output safety. Some model respond cautiously, while other may provide more detail than appropriate. Another weakness is operational details leakage, especially in gray zone prompt, where the wording sounds educational but still invite risky technical information. A third weakness is unverifiable information, since output are often not sufficiently grounded in trusted and current sources. And under opportunities, a structured prompt design is a strong path forward. Teacher in the loop deployment can also improve safety and relevance. Continuous monitoring is another opportunity because this system change over time and need periodic reevaluation. Under threats, dual use concern remain central. Even a small wording change can shift a prompt from defensive awareness to misuse-oriented content. Query escalation is also a real concern where student may continue proving until the model reveal more that it should. Finally, trust damage can occur if educator or institution rely on output that late prove unsafe or inaccurate. The SWOT analysis tell us what the adoption landscape look like. The next step is to understand why this failure happens. To move beyond surface level description, we used Fishbone analysis, also known as Ishikawa analysis, to identify the root cause of problematic output. The key idea is that unsafe or incorrect AI response do not usually come from one single reason. Instead, they emerge from multiple interacting factors. That is why a root cause framework is useful here. In our analysis, failure in cybersecurity teaching context arises from combination of model behavior, prompt design, knowledge sources, and policy or deployment conditions. This is important because it shows that the problem cannot be solved just by saying a model is good or bad. Safety depends on the full interaction between the model and the task. The user requests, the teacher, the teaching context, and the institutional control around it. So the Fishbone view complements the SWOT view. SWOT tells us the strategic picture, while Fishbone tells us the mechanism behind failure. On the next slide, I will walk through you the main categories in the Fishbone analysis. This slide presents the 5 main categories in our Fishbone analysis. The first category is model factor. This includes alignment style, refusal behavior, and overconfident tone. A model may sound certain even when it's answering in incomplete or wrong, which is especially risky in educational setting. The second category is prompt or task factor. Ambiguous wording, missing context, phishing, and gray zone prompt all affect how the model responds. In many cases, a prompt that appears educational may still invite operationally risk output. The third category is content risk factor. Some cybersecurity topics naturally carry procedural misuse potential. This includes content-related or credential compromise, attack step, or bypass-related mechanism. Even partial detail can be problematic in a high school setting. The fourth category is pedagogy factor. This includes age appropriateness, missing safety framing, over shallow explanation, or insufficient educational boundaries. A technically correct answer is still problematic if it is not suitable for the learner or the classroom objective. The fifth category is verification factor. This includes lack of citation, absence of fact-checking, missing teacher's review, and weak oversight mechanism. The main key takeaway from this slide is that technical fixes alone are not enough. Safer classroom use requires structured prompt, educational boundaries, and institutional oversight. Based on both of the SWOT and Fishbone analysis, we can now summarize the key insight and implication. This slide summarizes the most important takeaway from the study. First, defensive awareness works better than gray zone instruction. For well-known topics such as phishing, malware awareness, and two-factor authentication, responsible AI assistant can often produce useful definition, warning sign, and safe practice. And in those cases, the technology can support cyber awareness education effectively. Second, gray zone prompts are the most dangerous area when prompts become vogue, hypertechnical, or close bypass or exploitation topic, the risk increase sharply. Even when the output is not fully executable, it may still leak operational ideas that are not appropriate in K-12 classroom. Third, oversight is essential. Educator cannot assume that a fluent answer is a safe answer. Teacher review, structured prompt use, and clear classroom boundaries are necessary to keep output aligned with the learning goal and safety requirements. A broader implication is that the model selection alone is not enough. Safe deployment depends just as much on workflow design, review procedure, and governance structure as it does on model capability. So based on those findings, what should school and institution actually do? That is the focus of the next slide. Based on the findings, we developed several practical recommendations for school and educational institution. First, institution should be define a classroom safe scope. AI assistant are more suitable for defensive awareness, concept explanation, safe practice guidance. More sensitive topics, especially those involving bypass or exploitation mechanisms, should require direct instruction mediation. Second, school should standardize prompt templates. A structured sequence such as definition, warning, sign, safe, action, and reporting can help output educational and reduce unnecessary technical leakage. Third, institutions should implement teacher review, especially for high-risk prompt. The reviewer process is important before content is it's shared with the student, particularly in gray zone or technically sensitive area. Fourth, the school must protect privacy and safety. Prompts should avoid identifiable student information or real incident details. And institutions should define rule for logging, retention, and acceptable uses. Fifth, they should select suitable model and continue testing them after updates. A model that behaves safely today may shift after future changes, so periodic review is important. We also include resources adaptive deployment option. Low resources school may start with safe templates and clear boundaries. Medium resources school can add teacher review and allow or deny topic list. High resources school can establish more formal governance such as policy, enforcement, logging, and compliance check. Finally, I'll conclude with the main messages of the paper and for future direction. To conclude, large language models do have immediate value as a teaching assistant in cybersecurity education. They can quickly generate explanation, example, and awareness-oriented learning materials which make them attractive for classroom support. However, cybersecurity is dual-use field. That means even a small shift in parsing or context can move an answer toward unsafe, incorrect, or over operational content because of this. Adoption must be careful, bounded, and guided by educational safety principles. By combining SWOT analysis and the fishbone root cause analysis, this study provides both a strategic and casual understanding of responsible AI use in high school cybersecurity education. Our findings support a lean and constrained deployment model. Use AI assistant for being learning goal, use structured prompt, and keep educator in the loop for sensitive cases. In future work, we plan to extend the study in several directions. These include multiple turn classroom dialogue analysis, robustness testing across model updates, side-by-side model comparison, structured instructor feedback, and more systematic quantitative validation of the root cause explanation. Thank you for your time and attention. I'll end here and I'll welcome your question. Thank you very much for listening. I would be happy to take any question or comments.